Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 16, NEET Physics paper 2015. Students, let us solve the question number 16. A wind is with speed 40 meters per second blows parallel to the roof of a house. Suppose this is the roof of a house and wind is flowing with the speed of having a speed of 40 meters per second. Okay, it's flowing to this parallel to the roof of house. The area of the roof, this roof is having area suppose the area of this roof is A, which is 250 meters square. Okay, now assuming that the pressure inside the house is 1 atmospheric pressure, that is pressure inside is 1 atm, that is 10⁵ atmospheric Newton per meter square, 1 atm. The force exerted by the wind on the roof, how much force the wind will exert on the roof, and the direction of the force will be how much? Force on roof plus you have to find the direction. Okay, whether it is upward or downward, something like that you have to find here. So force, how to find the force? We have to use Bernoulli's equation. In Bernoulli's equation, we know that what is Bernoulli's equation? That is the pressure energy per volume plus kinetic energy plus volume plus potential energy per unit volume is constant for a streamline flow of ideal fluid. So for this ideal fluid, I assume that it's a streamline flow, that I can use Bernoulli's equation, that pressure plus half rho v square, and this is constant at any cross section. So if I want to write this equation, I'll consider any two positions, inside or outside, these two. If I want to apply the Bernoulli's equation at these 2 points, then because these 2 points are nearly at the same height, this will cancel out, and I'll get that for these 2 positions, I'll write that equations. For the point on the roof, I have the equation pressure there plus half rho v square, with which the wind is blowing, plus rho gh if I consider height of the building. Interior point pressure is suppose P2, half of rho v square, that is suppose if I call this B1, I call B2, V2 square, plus rho g h, because the height is almost the same, roof and the top. This will cancel out. This is 0 because inside the room is not moving, the air is not moving, the wind is still inside, therefore this will be 0, and we have the equation P1 square plus P1 plus half rho V1 square is P2. P1, I will consider the pressure what is there, and the difference of pressure, the pressure, because this is positive, this has to go to that side, P2 minus P1 is coming out to be half rho V1 square. This is the difference of pressure. We know that on the surface of any solid, if the velocities of the flow is more, if the velocity increases, then pressure will decrease. Pressure will drop. So for the roof, the P1 I have considered here, P2 I consider there, P2 is always greater than P1, then there is more pressure here, so the lift will be from below, so therefore the pressure is here, this P2 is more than P1, so the force will be in the upward direction. So this change in pressure is half rho V1 square. We know that the change in pressure is defined as the force acting per area. So the force is the pressure that is applied, the difference of pressure is applied on the surfaces, and this difference of pressure into the area of the roof will give you the force that is acting on the roof. Force on roof is this pressure into area. And what is this delta P? This comes out to be this. This delta P into A from here, and what is delta P? I'll put this one here, A is there. So this will become half A rho V1 square. So I have to substitute that. Force acting on the roof of the house is half A, how much? Rho V1 square. That is half A. A I have got in the question, which is 250 meter square. 250. This is the rho density, and that is given, density of the air is given 1.2 in SI unit, into V1 square, the speed of the air, which is 40 meter per second. So it will be 40 into 40. If I solve this, then this is 12 by 10. So this is 2 6 12. So this is 6. This 0 goes, this 2 goes. This is 150. This is 150 into, this is 40, or into 40. I will consider this as 60 4s are 60. This is 15. This is 4. 3 zeros there, and this is 15, and this is 4. 60 and 60 4s are 240. So this much of Newton, which is, if I see the option, then all the powers are in 10 raised to 5. I'll write in 10 raised to 5. 1, 2, 3, 4, 5. So it is 2.4 and 10 to the power 5 Newton. If I see the option, then 2 to the 2.4, 10 to the power 5 Newton. This is the value here. This also value is there, but this is upward and this is downward. We know that the force will act in the upward direction. That sometimes we know that will blow the roof. So always the pressure inside is always more than the pressure outside in case of a cyclone. So therefore the force will be acting in the upward direction from below, and this is the right answer to this question. Okay, thank you.